Hi, this video is for Thursday, March 26th for calculus. Today I'm going to be teaching you about evaluating limits analytically, but we're going to have to do some factoring first. So if you think, ugh, I hate factoring, I'm not very good at it, well, you can check out my YouTube channel for the videos that I posted about factoring. So here's my YouTube channel. Miss Webb teaches math. Okay, so last week I posted some videos for trigonometry to review factoring. So if you need a chance to review factoring, I've posted 2 separate videos about factoring that you can watch there. I'm going to do some examples on your notes that include factoring. So that might be enough of a review for you, but if it's not, you can check out those other videos. Okay, so evaluating limits analytically, sometimes you can just plug in what x approaches into the function and get an answer, and that's nice. But sometimes it won't work, and we have to try factoring first. Okay, so limits of polynomial and rational functions. If r is a rational function given by this equation, so this just means you have 2 different functions essentially, and you're dividing one by the other. Okay, and then c is a real number. So if we plug something in for x, it has to be a real number, such that the bottom part of the fraction does not equal 0, then we can say that the limit as x approaches c of rx equals rc, and that equals p of c over q of c. Okay, so like I said, sometimes you cannot just simply plug in this number. You have to factor first. So we're going to look at example 1. Example 1 is going to be, you can just plug it in, so that's kind of a review from yesterday. And then example 2 will start with the factoring. Now, I hope you guys got a chance to go outside today because the weather is very nice and it's great to see the sun for once. So around my neighborhood here, there were lots of cute little kids riding their bikes, and it was just very cute. So in all of this, you need some sunshine and you need some cuteness. So go outside if you can. Alright, so here we go. Example 1. Find the limit as x approaches 1. And here's the function. X squared plus x plus 2 over x plus 1. Okay, so here we can just plug in this number 1, and we have no problems because the bottom of the fraction won't equal 0 when we try to plug it in. So let's do it. 1 squared plus 1 plus 2 divided by 1 plus 1. So we know 1 squared is 1, so 1 plus 1 is 2, and 2 plus 2 is 4. And then the bottom part, 1 plus 1 is 2. And 4 divided by 2 is 2. So the limit as x approaches 1 equals 2. Okay, so that's a review from yesterday. Now we're going to go to example 2 where we're going to do some factoring first. Alright, so example 2, we have finding the limit as x approaches 1, and we have x squared minus 1 over x minus 1. Now, here the issue is, if you tried to plug in 1, the bottom part is going to equal 0, and we know that when you divide by 0, the result is undefined, so we cannot do that. And you're thinking, well, how can I factor that? Well, the top part here is called a difference of 2 squares. So that means you can find the square root of both terms, and then you can write the factorization like this. So the square root of x squared is x, The square root of 1 is 1. So we have x minus 1 and x plus 1 over the bottom part, which was x minus 1. So after you factor it, you're going to look at the top of the fraction and the bottom of the fraction, and you're going to look to see, could you cancel something out? And you can. You can cancel these terms out. They're exactly the same. And when you cancel them out, you're left with a 1 on the bottom and x plus 1 on the top. So now we're still finding the limit as x approaches 1. But if we plug in 1 for x now, it's not going to be a problem. So 1 plus 1 is 2. 2 divided by 1 is 2. So the limit as x approaches 1 is equal to 2. Okay, so again, that was called a difference of two squares. So you find the square root of both terms. You write one factor as a minus and one factor as a plus. And then you look at the top and the bottom of the fraction to see, can you cancel something out? And you do that, and then after you canceled everything out that you can, then you do the substitution method and plug your number in for x. Okay, so we're going to go on and try example 3 now. Alright, so example 3 says, find the limit as x approaches negative 3, and we have x squared plus x minus 6 over x plus 3. So again, you know when to factor these things. If when you tried to substitute what the limit is approaching directly into your equation, the bottom of the fraction would be 0. That's your clue that you need to factor first. So this is a trinomial on the top. So trinomial, you have to check out if there's a number in front of x squared or not. There's not a number there, so it's implied that it's 1. So we're going to take 1 times negative 6, which is negative 6, and we're going to think about what could you multiply to get negative 6 that would add together to be 1, because the middle term here is a 1. So I'm going to say that again. What could you multiply to get negative 6 that would add together to be the middle term of 1? So negative 6 is 3 times negative 2. And when you add those together, you get 1. So the way you write your factors for a trinomial is like this. X plus 3, x minus 2, and then the bottom part was x plus 3. Okay, so do you see anything that we could cancel out? I think we could cancel out the x plus 3 parts. So we're going to cancel those out. And now we're left with x minus 2 over 1, or just x minus 2. So we're finding the limit as x approaches negative 3 of x minus 2. So if we plug in negative 3 right here, negative 3 minus 2 is negative 5. So the answer is negative 5. Okay. So that's how you factor a trinomial, and then you cancel out the like terms on the top and the bottom, and then you use direct substitution. Okay, so I hope that made sense. Alright, are you ready for example 4? On example 4, we're going to have to factor the top and the bottom first. And it's going to be slightly harder. Okay, so example 4, we're finding the limit as x approaches 4, and we have x squared minus 2x minus 8 over 2x squared minus 3x minus 20. So I just reviewed with you how we would factor the top part, so let's do that part first. We're going to need to figure out, well, one, times negative 8 is negative 8. So what could you multiply to get negative 8? That when you add it together, it would equal negative 2. Well, negative 4 times 2 is negative 8. And when you add those together, they equal negative 2. So the factorization for the top part is going to be x minus 4 and x plus 2. Okay, so now when it comes to the bottom part, we have to do 2 times negative 20. So 2 times negative 20 is negative 40. So what could you multiply to get negative 40 that would add together to equal negative 3? Well, negative 40, we could have negative 8 times 5. Okay, because that multiplies to be negative 40 and it adds together to be negative 3. But because this 2 is there, when we write our factors, it would actually look like this. 2x minus 8, 2x plus 5. And I'm not writing that underneath here just yet because when you have factorizations like this, you need to simplify it one step further. Because I could divide both of these numbers by 2. So you have to make it as simple as possible before you write it in your problem. So if we divide these both by 2, and we leave the second factor as it was because I can't divide 2 and 5 by the same number. Okay, so now that's the simplified version. We're going to take this x minus 4, 2x plus 5, and write it up here. Okay, so let me erase some of this a little. We're trying to find the limit as x approaches 4 for this now. So do you see anything that we could cancel out? I think we could cancel out the x minus 4's. So now it's just a matter of plugging in the 4 for x and simplifying. So 4 plus 2 is 6. 4 times 2 is 8, and 8 plus 5 is 13. So the limit as x approaches 4 equals 6 over 13. Okay? So, like I said, if you have any questions about factoring, you're welcome to email me. You're also welcome to watch the videos that I posted to my YouTube channel last week for trigonometry about factoring. So there's a Google form on these things. It's not too many questions, just a few. Alright, so if you need help, let me know. I miss you lots, and I hope to see you soon. Bye.